Okay, welcome everyone. Welcome to this session on AI for metadata enhancement, metadata for AI readiness. With a cute little subtitle, how do we ensure a virtuous rather than a vicious circle? And I'll get on to that. I hope you find this session interesting. This is one of the sessions that I really enjoyed preparing, that I've been looking forward to, because I think there's some really interesting work going on, and I hope you'll find it extremely engaging and useful. I'll start, of course, with the acknowledgement of country. We acknowledge and celebrate the first Australians on whose traditional lands we meet, and we pay our respects to their elders, past and present. So I am not going to give a great deal of an introduction. I hope in the title of the session and in that little subtitle, there's everything you need to know about what we're trying to achieve. But I am allowing a lot of time for you to look at this particular slide. If you're the sort of person that has a mobile phone and likes to click on QR codes, then please do that now. And go to the shared notes, or you could even type in that bit.ly. The shared notes also include the agenda, but it would be really cool if people could write down their questions, write down their thoughts, write down some of their responses, the content of the presentations and your responses. Please also put your name and email. If you'd like to stay in touch, if you'd like to follow up on any of these presentations and developments. So, something about the topic and what we want to achieve. In the last little while, there has been a lot of work and a lot of discussion about how we make data sets AI ready. There's a whole load of seats in the front row here on the far side. So, Keith, come on. No, you've done it now. You do it now. No, actually, don't. Well, what would it be even better if people come around the front, in the embarrassing bit here in front of the screen, and sit down on the far side there. And don't stand at the back, please. Come around the front. Yes. Sneak in. Pretend we can't see you. Wonderful. Lots of work to improve the richness and quality of metadata to make data sets AI ready, to improve the way that they can be used for training or fine-tuning, etc. And at the same time, a lot of work and a really exciting potential for generative AI in various forms to help us with these tasks of data stewardship. And there are products available now. We'll hear later from Sean Hill and Fair Squared. And there's other prototypes to really accelerate and improve that task of data stewardship. That could be really exciting. But what happens in this to ground truth? How can we make sure that what we're doing in terms of metadata is being grounded on expertise, on decisions made by authoritative organizations about concepts and concept schemes, about ontologies, about authoritative terminologies? And what is the role of those things in this process? We'll hear a lot more about that from our speakers, so I'm not going to give any more introduction to that. We have a set of speakers. First up, we will have Rebecca Farrington and Kelsey Drucken, who will talk about AI readiness and metadata inference in Australia and beyond. After that, Deirdre Lungley will talk about the work that is going on for metadata uplift at UKDS. Then we'll hear from Pascal Heus, who will talk about work that he's been doing along the same lines, AI readiness, and in relation to enriching metadata with CDIF of the cross-domain interoperability framework. We'll hear from Slava Tikhonov, a colleague at CODATA, who will talk about his work for enriching metadata, for using CDIF, for using the variable cascade, and lots more. We've got Doug Phils online, who will who will speak also about semantic croissant and geo-croissant, and then we'll hear from Sean Hill and SenScience about fair squared. So that's a lot to get through. I'll try and keep colleagues to time, but very quickly, over to our first two speakers, and please introduce yourselves in more detail.
Yeah, hi everyone. My name's Rebecca Farrington. I work for AuScope, which is Australia's geoscience research infrastructure, and I look after research data systems. So one of the things that, I'll let Kelsey introduce herself a bit further when she comes up, but so one of the things we wanted to talk about just initially before we kind of deep dive into all of the progress with various AI agents and whatnot, was to talk about, I suppose from my end, the observational researcher experience, and then Kelsey's going to be speaking about some modelling experiences that we've had here in Australia. So I've just basically got this first slide here, which is talking mainly my take-homes, right? So for AuScope, which is Earth and Geospatial Science Research Infrastructure, we've got various different projects that are using AI in kind of, I suppose, pretty standard ways. We've had some prototyping of filling historical gaps of metadata from state geological survey records. We have software and modelling platforms that use, machine learning, various different types to identify, prospectivity for minerals, basin evolution, etc. We also have a virtual core library capability, which has high-resolution hyperspectral drill core, and there's some people looking at using various computer vision type AI for that, as well as a project that I'll talk a little bit more in a short period of time, Geophysics 2030, and modernising geophysics data sets. And a shout out to the National Computational Infrastructure staff here who worked on that project, Hannes. And I think Joe's right at the back hiding. So those two both worked on that project for us. And I suppose my take-home message is that for all of these cases, it's the provenance, so like the trust, risk, and the ethics, and all of the human side that we really, I feel like is important. So the technology, as we can all recognise, is progressing at increasing speeds, and there's huge amounts of value for that. But we can't tackle the research data in AI readiness without also tackling the AI readiness of our organisation. And that takes in all of the kind of bigger questions, I suppose, about adopting AI into our processes, as well as, legal frameworks, etc. I might skip over this in context of time. This is just what AuScope does, so we have lots of different instruments, lots of different researchers at lots of different institutions in Australia. So for our Geophysics 2030 project, there was specifically this case magnetotellurics data sets, collected very recently, started in 2017, and we wanted to try to curate that data ready for, machine-to-machine interoperability and AI data readiness for the future. And I just wanted to point out with this case, we had raw data, linking it through different processing levels, using a data catalogue at the HPC facility that has data curators, etc. But the huge amount of time that it took, and it was like the human hours that we needed to go into that I suppose at this stage we can't really see how AI could support that. So it's not just the scripting, etc. It was, there was cake making and digging through people's garages across the country to find data that wasn't even old. So, like things, there was that weird gap that, the COVID gap, I suppose. And yeah, it was only 4 years old that we found data still in contractors' garages was the only spot. And then that also then multiplies across all the different types of data, right? So that was just for magnetotellurics data, but we also have passive seismic data, we have distributed acoustic sensing data, and also there's other data sets that are really important to our community that we're not custodians of, but the amount of, I suppose, curation and support that is needed for those data sets means it's quite a lot of work. I'm going to pass over to Kelsey now to continue our story. I forgot to put the slide in, just to hammer home the idea of how researchers actually work. So this is how we get our data, right? So each of these kinds of examples, as well as the training case, are all intrinsically, human and human behaviour, and the quest for knowledge, etc., is grounded in what we do. I'll pass over to Kelsey.
Apologies. Good afternoon, everyone. I'm Kelsey Drugan. I'm an Associate Director at Access NRI, which is another national research infrastructure here in Australia. So I'm going to kind of expand on a few things from the climate perspective here following Beck. But similar to Beck, I wanted to put up front kind of our use case and activities that we're working on that really get to the AI readiness of us as an infrastructure. And these include embedding the data management practices into our software and data workflows, essentially trying to take away as much of that human intervention layer as possible for essentially making sure that our underpinning climate data has the key information needed from the start. And this includes uplifting sort of the curation practices as a whole. And this is to make the climate modeling output from that kind of native raw level more consistent, standard, and machine readable. But then also as kind of another layer to that, there's provenance, just like Rebecca mentioned. And for us, this is really critical for both provenance of the software workflows and then the data parts as well. To just quickly help orient you for this, this is a kind of very high-level workflow of the software and data bits. Grayed out are other parts that I won't focus on quickly in this in these slides, but basically with climate modeling, you have physical equations that get approximated and then solved in numerical simulations. So that's a bit of software, very complex software code, I should point out, with many different pieces and versioning and change histories that become quite critical that may or may not be understood at the time of creation, but later through AI and reuse, are quite important. And then when data is generated, then there's a whole other chain of provenance, and there's where our data curation and uplift and FAIR is really critical for us as well. And I should point out too, we're working at pretty large scales relative to most of the Earth and environmental communities. So for us, small is still in the hundreds of terabytes scale. And then when you think of collections of information and things to feed through future AI activities, it gets up to easily petabyte scale. So very quickly, for us, the current state, this will be a one slide or two slide max, I think. We have different levels, if we use the analogy from Rebecca's talk, in climate simulations. We also have different processing levels. We have the raw modeling output. We have people that want to slightly process that to improve it for usability. We then have those that want to highly process that for bigger international collaborations and sharing. And so for us, what we're trying to do is really look at that native output and put as much of the data management and provenance practices in from the start. And we're aiming so that, our current state right now, you can see lots of red X's, and we're aiming to make sure that we can at least have, a level of confidence and make a step across really key data curation aspects. We're, starting with the low-hanging fruit, and then we can put this into our release workflows with the software, have this become, standard specifications that not only work with the confidence of the software release cycles, but then also for all the downstream data products. And so just on that provenance side, I wanted to point out, here actually is a figure from a paper talking about machine learning applications for climate modeling. And there's not only complexity with how you run these models, there's complexity with the different input data that go into helping to set up your simulations. There's data coming out, of course, from the simulations, and we've got both these data and software workflows, again, that we'd like to make sure that we can embed with confidence information about those provenance chains. So I think that's my last one, and the key take-home, I guess, from activities that are going on for us as a climate infrastructure here in Australia is really trying to embed and automate these practices as much as possible to have that very solid foundation for future AI applications. Thank you.
Thank you very much, Rebecca and Kelsey. So please do note questions for the end. We will try to get through all the presentations, and then for time management, it's always easier to have that discussion at the end. Our next speaker is online. Deirdre, can you hear me?
Yes, Simon.
And we can hear you loud and clear. Fantastic. Glad that you've been able to make it. What time is it there?
7:15.
7:15. So in the morning. So it's not too...
Yeah.
It's all right, isn't it? Okay, good, good. Thank you very much for joining us. Okay, so I will click through the slides on your instruction.
Great. Thank you, Simon. Good afternoon, everybody. So I'm Deirdre from the UK Data Service, and this talk is work that I've done with my colleague Jacob Joy and my colleagues at Closer UCL, John Johnson et al., and University of Surrey, Soprana and her team. Next slides, please, Simon.
Can you put the slides up, please? At the back? Yeah, thanks.
And it's a UK ESRC Future Data Services funded project called MetaCurate ML, and this is all about using machine learning AI to enhance metadata, so it could be used by emerging European data services that are becoming available, and in future readily utilized by AI ML technologies. So the parts of this that I'm going to talk about are metadata extraction, vocabulary alignment, and automation of disclosure control. So with metadata extraction, a lot of our social science data is locked in what we call non-machine actionable formats, mainly PDF questionnaires. And often what we end up doing is just giving a link from our data catalogs to the questionnaire, which isn't sufficient in this machine action, machine actionable world. So so our first step is to extract the questions and routing, etc., from these questionnaires and make them available to researchers to better inform their decisions. When it comes to vocabulary alignment, our Closer colleagues have a very rich resource. Closer Discovery has variable level concept data, which is useful, but it's currently a bespoke system, a bespoke concept scheme, and as part of this project, we were Closer aligning this with with ELST, the European Language Social Science Thesaurus. Both we and other colleagues around Europe, I think the Norwegians and Hungarians, have been using this resource as training data for machine learning. And when you've got all of this extra metadata, automation of disclosure control is an example of what can be achieved with this, what we call metadata uplift. Simon, next screen, please. So this is a colleague. This is from our colleagues at Surrey, and it's showing how they're using a multimodal model, which can simultaneously process document layout, spatial relationships, and textual content. So they're taking the PDF data, and the end result would be DDI lifecycle with the question text and the routing embedded. So although the project has come to an end at the end of September, we've got a little extension to improve put that in as into our ingest pipeline and make it available to our data catalog. Simon, next slide, please. And this is just an example, just to show you the Closer Discovery versus the ELST thesaurus. And by aligning these, it makes that data available to our European colleagues. Next slide, please. And this is a slide from our automated disclosure control. And what you can see here is that we've used machine learning to identify the sensitive variable, what we call key variables. These are variables that when used in combination could be potentially disclosive. I think the example I tend to give is if you had normally we say that geography it trumps everything, but in a case where you've got let's say a woman, you know, 60 to 65 age group, an aeronautical engineer in the northeast, it starts to become quite, you know, there aren't a huge number of them, and therefore you start introducing disclosures. So by automating the combination frequency calculations and having this metadata uplift, where we not only recognize these when we say key variables, we're talking about socio-demographic characteristics, such as, you know, in this case, marital status, country of birth, sex, and religion, but also we also align the variable representation to our concept schemes, and these are all held in SCOS, and by knowing exactly which level of the hierarchy they're at, we can reduce the level of detail. So, for example, here I give the example of going from a very detailed country level up to another level, and so reducing the what we call violations and allowing click button mitigations. So this type of thing, if done manually, can take a considerable amount of time. Okay, next slide, please, Simon. And all of this this metadata uplift is achieved through a pipeline. At the moment, we're using our AWS step functions, and what you'll see here is that each step, each classifier, we identify our key variables, we identify functions such as weight, but at each step there's a human intervention. So we have curators reviewing the results of AI and ensuring that they're in control. I must stress this is a prototype at present, and we're gradually going to roll this out within the archive here at Essex. Next slide, please, Simon. And this is an example of one of the review screens. You can see it's what we call a classic React UI, and the curators can quickly check and accept or reject what the models have identified. And then next screen, Simon. But we're also looking at more modern kind of AI assistant technology, and we're looking at when it comes to reviewing the alignment. We decided to have a look at agentic AI and exposing the tools available, the functions available as MCP servers. And I'm going to run a little video next just to show you how that works. But the idea at the moment is that we have two. Currently, we have built two clients. One is AWS Bedrock hosted, Claude Sonnet, and this is available for our metadata. But for microdata, we're hosting our LLM, our client LLM locally, and we're using Mistral. And so we're currently working on server 1 and 2. Well, sorry, 1 and 3. But today I'm going to show you one where the outcome of the alignment can be checked by the curator and amended. So Simon, if we can step through that, and I'll just explain that to you. So here we're going to look at the religion alignment, and it's if you can see, it's not done a particularly good job on this one. So we're seeing that number. It says it's other religion aligns to prefer not to say. So I'm showing you the functions that are available. You can fetch the hierarchy and explore it, and then you can amend. And so here we can see that it's using the religion detailed level 11, so let's look at that level and see exactly what it is, and we can see that it should be other religion should have been 10, not 11, and the curator can simply use another tool available and update the alignment manually. It then, once they've done that, all of this data is then held in a graph, so the data going through is accepted only after this change. So we're changing here.
Sorry, sorry, Deirdre.
Sorry, it's just,
I thought you were still...
It's doing the final stage, it's doing the automatic update for me, Simon.
Right.
No, don't worry. But,
okay.
but yeah, no, don't worry, it's fine, let's leave it at that. But it's
showing
so
again, sorry.
Yeah, and there you can see it's automatically updated it, and it's available to the, all of these tools are available to our curators. So what we're thinking of going forward is that a lot of functions that we might subsequently embed in pipelines can be tested with this kind of agentic framework. We're currently looking at abstract classification with keywords. We're testing this out with an AI assistant interface at the moment. Okay, and I think that's my final slide, so I'll hand over to you, Pascal. Thank you, Simon.
Thank you very much, Deirdre. I'm sorry I jumped away from the video. I thought it had finished. My bad. But thank you very much, and thank you very much, Deirdre. And for that very concrete example of the use of AI in the loop. That was fantastic. So next up is Pascal. Pascal, can we hear from you, please?
Hey, Simon, can you hear me okay?
Yep, fantastic. Welcome. It's late for Pascal, who's in Alberta.
It's just past midnight. Yes.
Just past midnight. Okay, thank you very much. And if we can show the slides, we'll kick off with Pascal's presentation.
Yeah, go ahead. So
please introduce yourself and your title. Yeah.
Calgary. I would call myself a freelance researcher. I'm so quite involved with the CODATA, and I've been involved with data and metadata for almost 2 decades now. I want to just touch upon a few things that are happening in the AI space in CODATA. So you can go to the next slide, Simon. The first thing I want to put a little bit things into context, because I think this is important. We feel we are very distracted by AI lately. And I like to talk about not AI, but about machine intelligence that I see as an ecosystem. As I said, AI is dominating our world. We hear of AI all the time. It's changed everything every day, and things change very quickly. But while it is likely true that it's changing everything, it's critical not to forget that it's just a new piece in our toolkit. It's a big piece. It's a big wrench in the toolkit, but it's not just a standalone solution. We cannot solve everything with AI. So I'd like to see machine intelligence as an ecosystem that combines AI with several other elements that we care a lot about, including data, metadata, APIs, infrastructure, and related best practices. For example, it's clear that AI needs access to high-quality data and machine actionable metadata. Chatbot agents, LLMs would not work without data and metadata and APIs. Likely, if you look at fair data, well, data needs machine actionable metadata, and this is commonly hard to combine, but AI has a major role to play in creating such digital knowledge because it brings new skills and agents and helpers. AI can also produce assistance for data production, publication, or analysis, and storytelling is a strong suit of AI. So AI is also basically a data and metadata producer, and we have to take that into account when we work with AI, that make sure they are, people that use AI also adopt best practices. And importantly for me, which is one of my favorite topics, all of this cannot happen with the APIs that are really connecting the dots between all these different pieces. But machine intelligence is really a big ecosystem. So it's critical not to be completely distracted by AI and put all our eggs in one basket. We have long-standing efforts to improve data and metadata, and that needs to continue. So this is a mission I'm kind of keen and proud to be part of through my participation in CODATA, an open source project. And there's many things. Talk a little quickly on one of my favorite topics, which is APIs, because I want to many people to keep thinking that API are critical. And then I give you a quick update on some of the CODATA activities I'm involved with. So if you go to the next slide, Simon, I really want to emphasize the important and critical role that API plays into these ecosystems. I mean, API, that can also be called web services, are really the backbone of our digital universe we live in today. They connect these different systems and resources in generic ways that isolate tools and applications from each other. I mean, cyberspace as we know it today will not exist without API. Unfortunately, they're often very invisible, so people have a tendency not to think about that. But it's really important to think that no digital communication or conversation will take place, would be able to take place without APIs. So we need APIs everywhere, and this need obviously extends to AI as well. For example, from an AI perspective, application and chatbots are needed to communicate with LLMs. Agents to talk to each other need API, or to access tools, they need APIs. You probably have heard about the message control protocol, or MCP. Well, this mostly built on top of APIs. And also people that work with model and machine learning need API to access data. So API cannot be ignored. And that's the first thing that I would like to convey is, like, if you work in anything, whether it's data or AI, just don't forget the APIs, because they're really connecting the dots. But when you start diving into APIs, it's also important to make sure they design with the good and best practices in mind. For example, you should not release an API without specifications. You may have probably heard of OpenAPI for REST. There are other specifications for the protocol. The specification is a bit the equivalent of a data dictionary for a data set, if you're not that familiar with APIs. So it's also used by AI agents tools now to automatically try to discover and understand what an API does. So it's critical for agents or to generate software development kits. But we also must go beyond these specifications. So like for data, we have to provide documentation with data. Well, the same thing is true for for APIs. You can give the spec, but you also have to document your API, which is very important. So you must have developer portals and all this additional documentation. Also make sure to be aware of all the API technologies that are out there. Obviously, most people are familiar with REST and open APIs. But there are other protocols and APIs that have been emerging in the past 2-3 years, especially GraphQL or Async API or WebSocket are very popular. So make sure if you dive into API, think about the entire ecosystem of API. Likewise, if you work with Sparkle, if you happen to have triple stores and semantic web, which are fantastic, be aware that a lot of people do not know Sparkle and are not familiar with RDF. And it's a very good practice to layer more traditional APIs on top of the Sparkle endpoints. For example, GraphQL is actually a pretty good API technology to put on top of RDF store, which then suddenly makes your semantic knowledge accessible to more traditional developers that may not be familiar with semantic technologies. There are lots of tools like Postman to make what I call API fairs. I think APIs, just like data, must be findable, accessible, interoperable, reusable. So applying the FAIR principles to APIs is also, I think, a good thing to think about. But as I mentioned, whatever you're doing, whether you're working with data and AI, just don't forget that API are a core component of your roadmap, and they should be present there. And always remember that there's really no digital conversation for AI, fair data without APIs. So that's kind of my message here. There's also an interesting survey that is done every year by Postman that was just released. So if you want to check that out, I put a link in the slide. There's some interesting thing. Obviously, the strong focus on AI this year that indicates that like a lot of developers use AI, but not many develop API for agents. And the idea to develop API for agents now is really important. It needs to change become part of your roadmap in the year or two to come. So I'll stop here about APIs. Obviously, it's one of my favorite topics, but I just want to remind everyone that whatever you do, probably API has a role to play. So keep that in mind. All right, on the next slide, Simon, I want to.
You've got 4 minutes left, Pascal. You've used quite a lot of time on APIs.
Okay, sorry about that. So I just want to mention that we now have an AI Readiness working group under CDIF that has been working on a couple of things. One, we've been trying to figure out what AI Readiness means for CDIF. And we realized it's actually really depends on the context. So we have developed different use cases, the chatbot use case, machine learning use case, metadata inference, responsible AI. So we try to come up with different definitions for different use cases. We also are trying to define measurable readiness. So we're coming up with indicators of readiness around at different levels. We're trying to measure readiness at the framework level, metadata specification level, or technical implementation level. So if this is a topic that interests you, it's a small working group. We try to meet occasionally. So do reach out. There's also a form you can use to sign up if this is something that interests you. And then on the next slide, and I'll try to be quick on these two, Simon. Want to give you an update from the digital representative unit of measurement, which is a CODATA group working around this topic. One of the efforts I'm leading there is around the fundamental physical constants, the definition like the meter, the kilogram, and all those type of things. These things are published by the National Institute of Standard Technology in the US in kind of, for me, legacy formats like ASCII files and websites, which is not really machine actionable. So we've been working on that for the past couple of years. We just did a major update and now have this information available in an RDF graph. The next step is to upgrade an API that we had designed a couple of years ago. So this will all happen in the probably months to come. So if you're interested in fundamental constants, there's a GitHub repository where you can find this in RDF and look for a new API coming up in 2026, early 2026. And finally, Simon, I want to quickly mention that obviously we have the cross-domain interoperability framework under which many things have been happening. We have broken down after the successful report, we have organized many different subgroups on different topics. There's AI readiness, data provenance, data description. I would encourage you to reach out and look at if there's a group that interests you there, please reach out and participate or just follow to see what's going on there. We're also extensively involved with the Croissant specification, which is a task force led by Google and Open Data Institute. Croissant being a rapidly growing specification for the discovery and use of dataset for machine learning purposes. So we're making sure everything we do in CDF with DDI and all things also aligns with Croissant and vice versa. We're trying to make sure Croissant is aware of all the things we are doing. And we work together into connecting the dots between AI specifications like Croissant and all the stuff we're doing under CDF. And I'll stop here, Simon. I think that's the major updates. There's more information that I can give you. Just send me an email or contact me if you want more information on any of these things. Thank you.
Thank you very much, Pascal. So I think that was great. Please do look up Pascal's work. The work on fundamental physical constants is a key input to a lot of data sets, and the work of the CDIF group is going to be very useful as well. I'll hand over now to Slava, who's going to present, or you're presenting the whole blog? Yes, okay, so Slava will essentially give two presentations now on behalf of himself and work that they've been doing, and we'll hear a lot more about Croissant.
And GeoCroissant. Okay, so Croissant. So a few years ago, Harvard University approached me because I'm working on Dataverse platform development, and actually Google came to them this question, if they want to work on a specification for machine learning. And I've got incorporated in the group and started to work on that, and this is the result of this work. So initially they didn't have good name, but because it's Google DeepMind in Paris, so they went for lunch, and it was nice lunch in Paris, so apparently they call it Croissant. And why it's so important, this standard? So apparently, we didn't have any kind of possibility to connect industrial resources and data sets produced by industry and academia. And this standard actually allows to leverage everything and connect them. So as you see, there are commercial platforms. You see Kaggle, you see Hugging Face, and in the same time, there is Dataverse, OpenML, and some other platforms started to support Croissant. So basically now we got possibility to link them together and, for example, just to get some data sets from Kaggle, put in Dataverse, apply some interesting tools, and enrich, for example, with extra metadata and connect control vocabularies and put it back in Kaggle. So this is a great process, and you can do it like semi-automatically because you are applying also machine learning techniques. And even more important that Croissant is being used to train models. So as you see, PyTorch, TensorFlow, and Keras, and some other machine learning frameworks supporting Croissant out of the box. So you can just download Croissant and put it inside of any framework and train a new model. This example, how it looks like. So if you have some CSV file or JSON-LD file, you can just define logic, and basically you can make a split in test training sets and validation sets, and you can train your model. Very simple and very efficient. And after discussion started, okay, so now we've got Croissant, and what we can do about this Croissant, because obviously different data providers, they're not producing data in same style, and also they're not AI ready, really. So we started discussion about connection to external control vocabularies and also alignment of ontologies. And I started to lead group, which called now Semantic Croissant. And this group is actually working on a connection to external resources. And what is very interesting, so semantic croissant is graph. And this graph, of course, you can query, and you can also get subsets, and you can link to some parts of croissant, real croissant. And also you can ask AI to enrich metadata, and you can do basically asking questions and some other things. And you can see it as a kind of possibility also to link vector space, which is in vector database, with knowledge graph. And I'm doing this by using MCP protocol. So there is a model context protocol created for Dataverse. And I will show you some examples afterwards. So ontology alignment, this is like first task that we'll do. In this example, for example, we have two different ontologies, two different schemas. So first is from data side, and we have field called publication year. And from other side, we have code meta, and field is called date published. So in this specific case, it was trained to recognize different fields and make prediction if it can be linked. And because it's not direct match, it's also giving you some kind of ideas what kind of other fields could be linked. And by using this and doing this exercise, so there is also human in the loop, you can actually map different fields from different schemas and show to AI that you can basically use it also for your purposes. Another task is about automatic linkage of control vocabularies. So in this example, how we're linking to Wikidata automatically. So we're basically querying Wikidata Sparkle endpoint. And if you're asking some questions, it's bringing you a lot of candidates. And after we're taking similarity between what is being asked and what is being returned. And if there is threshold, let's say more than 90%, you can also create a link, and you can put this as a link to control vocabulary value. This example, how it works. So for example, if there is Hotel California as a song by Eagles, so it's been recognized as a song, it's been linked to appropriate concept from Wikidata. But if it's not a song, it's something else. It's a movie inspired by song. So it's already a difficult case. So you have to apply different context. So in this example, context is basically movie, and it's resolving to completely different Wikidata entity. But if it's not this movie, but there are two actually movies, and you're using here to leverage this, and you're getting, again, completely different entities. So by using this approach, you can resolve to different entities available from Wikidata or from any kind of control vocabulary, and AI is basically making right choices. So this is next level, what we did. We started also to use automatic translations in the context, and context is coming from Wikidata. So we just need to be sure that information from Wikidata is already inside of models, so they trained on this. And as soon as you know that it's there, you can also create very nice and accurate translations of your concept. So from this example, you can understand that there is energy. It was translated, I believe, in 12 languages automatically. But in the same time, because it's linked in the graph, it's also able to produce description automatically. So there's concept description, and there are also relationships which are also produced completely automatically. So this scores, broader and related properties, they're coming from factual sources of information, because we are using also Wikidata as our ground truth. So now, interesting topic, MCP for Dataverse, Model Context Protocol. You can also just go on the page in GitHub and you can install it in any IDE, like Cursor, Visual Studio Code, or something else, Cloud, for example. And you can just connect it to IDE and ask these kind of questions. So first question is about navigation. So I was asking how many installations in France. And basically it does understand what I'm asking because there are like tools and every tool is dedicated to run for specific task and bringing me answer. But in the same time, I was asking how many datasets about specific topic like climate change in Harvard Dataverse. So it's again recognizing what is being asked. And now it knows that it has to go to API, to Solar API, which is how Dataverse was implemented on Solar API, query it, bring back information, and do interpretation. So there's a link, and you can make a photo and try. Another example, so it was navigation layer, which is kind of you asking generic questions and you want to find some information. But in the same time, you can connect to specific data set. And here croissant is really powerful because especially semantic croissant, which is linked to control vocabularies and ontologies, because it precisely understands the topic of every field. And you can ask questions literally about metadata, but also you can go to data and asking like, show me files, explain every variable from file, and explain units of measurements, how it was measured. And now we're coming to CDIF. So another extension that we produced is called GeoCroissant, and this work is being led by NASA. And why it's required? Because NASA wants, of course, to do processing of all their materials, and they have a lot of materials from other planets. So, of course, it's quite difficult to create geospatial representation of photographs, and they don't know where photographs were taken. So there is extension, and actually, if you also train models on these models should be able to fill all these new fields, which I introduced here, completely automatically. And after humans should be checking, validating, and it will become part of data sets. Now, it was already discussed about croissant, but what is real relationship to CDIF? We see it as a croissant as a digital library. So basically, if you're looking for some information, you're using generic keywords. You probably don't know what you're looking for exactly. So you're going to a library, you're asking questions, and librarian is bringing you books. And now you have to understand which page you should open. So you have to get access to expert knowledge. And expert knowledge is basically CDIF. So we're turning generic representation to expert knowledge, also showing to AI, and AI does understand that, and it's able to also to answer any kind of questions. So you can see it like this simple representation. So you have metadata and contents of the book. So this is croissant, but in the same time, CDIF could be represented as index with all terms in the end of any book, scientific book. Thank you.
Thank you very much, Slava. So now we have Sean Hill from, and I'm going to, from SenScience. Sorry for the mind freeze there. Who will talk to us about the work that they've been doing at SenScience with Fair Squared and Metadata Enhancement. Sean, over to you.
So thanks a lot for having me. And Cristina Gonzalez, who's our AI data science lead, is just wave. Yep, she's here. And we're at booth 12 in case you're interested in following up on any of this. So yeah, I want to take you through it. It follows perfectly on what Slava was talking about. But what we're tackling is just this challenge that I've been dealing with for decades, and I'm sure many of you have been too, that research data in general is not easy to find and preserve and reuse, and scientists aren't really getting any credit for it, and it's just a big, huge loss that we're losing all the data that's being generated, and many of it won't ever be funded again. So how do we tackle this? How do we start to make it easier, but also how do we make it valuable? How do we make it really worth actually preserving? And the current data management solutions, from a scientist perspective, are really hard to actually use. So we've developed Frontiers Fair Square Data Management. It's a system that manages the full data lifecycle after the collection of the data, to curate it, certify it, publish it, preserve it, reuse it. It automates the process. I don't think I have time to talk too much. I have to move forward. But it is built on a specification called Fair Squared. Fair Squared builds off of ML Commons Croissant. So all of the things that Slava was talking about are actually, to a large extent, leveraged by this system. And then we've added on top of it detailed provenance, scientific units, credit ontology, a lot of these pieces that are needed for the scientific publication and scientific reuse. And so let me just hop here. So these are some of the standards, open standards that we've built Fair Squared on. And the idea is, although we're a startup, a commercial company, Fair Squared is an open specification. It will be governed by independently of the commercial side. We want it to be fully open, community oriented, and continue to develop. And the way that this process works is a scientist comes to the platform with their data and their documentation. The Fair Squared platform, the AI, processes that. I'll take you through that in a moment. And creates a number of data products. One is a data package, so it's essentially a metadata package based on ML Commons Croissant and et cetera, produces a data article, produces a data portal, and produces a certification that it complies with the Fair Squared aspects in terms of the FAIR principles, plus AI readiness, plus responsible AI. And then all of that is submitted to, in this case, Frontiers, one of the Frontiers journals, for peer review. That whole package is peer reviewed, and then once it's accepted, it gets published for credit, essentially. It's essential motivation for scientists to get their credit. So this is going to be a little bit commercial for this audience, but it's the best video I have of the latest version of the platform. So let me just, let's see, how do I get this to play here? It did play in the Google Slides before, but there we go.
To Fair Squared Data Management. Get ready to start your AI-driven data management journey with Frontiers. Tasks that once took months of manual work will now take just minutes. To get started, you need a Loop account to connect via Frontiers submission system. Methodology document describing how your data was collected, processed, or validated. A structured, tidy data table. Ready to transform your data sharing? Once you've signed in, Clara, our AI data steward, will prepare your project space. Customize the page to suit your preferences. Clara will give you prompts as you go. Use the chat box to collaborate with her directly. She can even change language preferences for you. Simply drag and drop your files to get started, and let Clara guide you through composing, curating, and visualizing your data. On this data table example, you can see that each row is one observation, each column is one clear variable, and each cell only contains one value. She will generate a title, author list, keywords, and initial summary for you to review. Once you are happy with the information generated and have included all relevant data sets, you can begin data curation. Your methods section is now being extracted and organized from your uploaded documents. Clara will prompt you when it's ready. You can edit any of the sections, and Clara will review these for you and help you to refine. Next, a data dictionary is created to describe each field in your data set. This is an important step for ensuring your data package provides common understanding of data by defining its structure, relationships, and attributes. This eliminates ambiguity and ensures data is interpreted consistently, by both humans and machines. Clara will tell you what to look out for during this step. Now the fun part. Let's start visualizing your data. Clara will make recommendations on the best ways to visualize, and if you agree, ask her to go ahead and generate those figures for you to review. You can explore the figures and ask her for adjustments anytime. Select which figures you would like to include in your fair squared data article. Now you can work together to prepare your article for submission to a Frontiers journal. Clara will take you through each step of the article curation, from abstract, introduction, and methods to the data overview, which comes with a fair squared certification, recognizing that your data not only meets the FAIR principles of findability, accessibility, interoperability, and reusability, but is also AI ready and responsibly reusable. Review each step and ensure the data overview clearly describes contents, structure, and key features of your data set. If you need to make any additions, just ask Clara. Now you can start seeing your article come to life. Review the displayed visualizations that you chose earlier in the process, along with their described observations. Data Explorer is an interactive portal created uniquely from your dataset and article, which will be published alongside your data article. Take a moment to explore its features. Dive deeper into the dataset, playing with the filters at the top, before you move on to a final review of the interactive Fair Squared Data Portal. And your article is now ready for submission to a Frontiers journal. Together, we are reshaping data.
Okay, I'll skip the shiny ending. But if now I go back. There we go. Thank you. Just to wake you up. So just to give some examples that you can go to, and of course come to the booth, and you can see many more examples. But this was the inaugural Fair Square Data Portal, and this was for 30 years of maritime data, marine biodiversity measurements. And this, if I can play it, I don't dare. I don't dare. It basically is a portal where you can go and interact with the data. You've got that Data Explorer custom built. And then you also get the AI agent, which I'm just going to skip ahead to, where you can use Clara to talk to the data set and basically ask questions about how is this variable measured, what does this mean to me as a policymaker, or why should I fund this grant again, or any kind of question you want to ask about reproducing the experiment or understanding the data. Now I don't want to get Phil back. I'm just going to go to PowerPoint, and here, I think I did it. I think I can manage. And then there's that accompanying, so these two are paired, the data portal and the data article are interlinked. And the authors have been very happy because they get lots of attention and citations, and then every portal comes with a custom Jupyter notebook built so that you can directly load it up in Python, analyze it, reuse it immediately. The compliance certificate is nice to show your funder that you're actually fulfilling the FAIR requirements. All of this, I don't know how much time I have. Okay, last minute. It's built on things you might assume. It's an agentic, multi-agentic system, leveraging multiple different LLMs. We always keep human in the loop. We want humans always validating, checking, verifying, and of course it gets peer reviewed. There's a semantic knowledge graph behind this for the RAG. We do support, for example, having the data, the single source of truth being in community repositories or in data sovereign locations, essentially, while also keeping it accessible in the cloud. And we do have a model context protocol interface as well, so that you can do lots of things with this data. So I think I'll probably just stop there. Thank you.
Okay, thank you, Sean. Sean, please don't go back to your seat. Could you take a seat here? Slava, could you come out? And Kelsey and Rebecca. Cristina, I don't know if you want to be part of the panel as well. There's a seat there, and we have our two colleagues online. So thank you very much for those 5 presentations. I hope you found those fascinating. I think it's a very exciting but also challenging world that we're entering upon. There's some really notable examples there of semantic enhancement, metadata enrichment. We heard from Rebecca and Kelsey a sort of a call for organizational readiness. I think I'd characterize it in that way. Deirdre online talked about metadata and uplift and the role that human-in-the-loop AI can play in metadata enhancement, specifically to make the management of access to sensitive data more efficient. And that's a really important objective for social science data archives and other organizations. Pascal made an appeal for webiness, APIs, and talked about the work that he's been doing on fundamental constants and units of measurement, which are an important source of truth in that graph that the AI can use. Slava spoke about semantic croissant, geocroissant, and also stressed the variable cascade in CDIF as an important input and source of truth for that semantic enhancement, that metadata in data sets. And then we saw an example of that in a similar way from Sean and Cristina in Fair Squared of how that metadata enrichment happens for a specific data set and how the user can clarify or enhance the description of the specific variable or measurement that is presented in their data set, as well as all the nice stuff about visualization. So I hope that's quite a rich set of presentations. I'd like to throw this open immediately if there are any questions from the audience and any input, any questions for clarification, any observations. I'm seeing someone at the back, and I'm seeing hands going up straight away. I'll go to the back first. Oh, hi, Mark.
Hi, Mark Hannell from Figshare. It was just an interesting thing at the end there with the Fair Square stuff. It's really cool to see innovative stuff and like new things coming out, and it's really cool to see it's built on the stuff that everybody else is doing and cool stuff like that. I just wondered, my thought was, what's the point in peer review? And I just wanted to know, what is the peer review process for these outputs? No, what's the point in peer review in general? Just these ones.
So actually, we give a questionnaire to the peer reviewers because it is a kind of quite a different peer review. But the point of this publication is that it should be reusable data. You should understand the limitations of it. You should understand the value of it. You should understand the questions you could ask from it. And it's looking for. And it's actually been interesting just to go through the process because it's so new. But the peer reviewers have actually come back and they said, well, you know, it's not really clear. Maybe this you know, can you actually use it for this? Or the number of missing samples in this dimension, is that going to be useful to answer? It's other scientists in the domain thinking about how can I reuse it. And since they can actually pull it up in a Python notebook, they can try stuff, look at it. The test is it garbage? Is it something that's that's useful? And I think peer review is great for that because you also want to make sure that they can read through the article and it makes sense, and they're able to understand the data set then in a way that a README and a zip file maybe isn't sufficient. So I think it's a new way of just making sure that data sets are really truly accessible and reusable. But that we want, we don't want this to be something where people put stuff into an API and spit out something that doesn't make sense. So
maybe this puts peer review back in its place, which is what's the contribution to science, and is that valuable?
Exactly.
Is the methodology good
That's
and
right.
appropriate? Is this good science? And you have something else doing the neglected task of saying, does the data conform?
Hello, it's very interesting, all of this. One of the things that I've
Please
found...
introduce yourself as well,
hello.
sir.
Yes, Eric Laurie from the Australian Institute of Marine Science. I wanted to hear your comments on how challenging it was to make a robust AI workflow. Generally, large language models are very good at handling information that they're well trained on, but often scientific research is at the edge of the knowledge, and so they're far more likely to misinterpret or hallucinate, in which case making workflows that produce robust outputs, I imagine, was very challenging. So I was wondering how you base that.
I think what's important is that we're never using the language model for the content. It's about how do you extract from the content, organize it into a structured representation from which then the LLM can then synthesize something and organize it. I think that's a critical piece, because otherwise you will have hallucinations, right? All of this is in a sparsely sampled field, right? Many scientific domains are not, overtrained in the LLM space. So that's the critical piece, is using it for what its strengths are. And to do that, in this day and age, you simply have to build a semantic knowledge graph behind the scenes. Right? I don't know of another approach.
I want to get back to a couple years ago, and because I was also watching how Google and Meta did that from scratch. So it was quite a process when we started to work on Croissant and we started to use that. For example, Gemma 3 was trained on Croissant. So when we started to select different models, we started to ask Meta and started to ask Google and someone else, who is training on Croissant? And Google told me, use Gemma 3. Even 4 billion should be good for your data. So as soon as Croissant, like metadata and data from Dataverse started to become training set, it started to improve quality because this is a graph. So step by step and release after release, we started to get into, high quality in a way. And I believe as soon as Ception will be, so what I showed, actually Croissant is language, how large language models talking to each other right now.
So I have 3 questions for 3 speakers, but if it's too much,
Okay,
I'll try to make them quick and mostly just check. So first, Kelsey, right? Yes, Kelsey, I really enjoyed that presentation, that work, very rigorous, very useful. I just wonder if you're building workflows that are reusable in other contexts, because, for example, at the Barcelona Supercomputing Center is a whole earth science team that I wonder if, could be something that could be shared to apply in another setting, in another environment. So,
yeah, the short answer is absolutely. We work in a very open development kind of space and ethos, and
you have like a pipeline or so.
Yeah, and the concepts really aren't specific to the climate domain, but the climate modeling example just brings out a lot of the complexities where it's not something that can be easily handled in the post-processing steps. And actually, I think just to the last question here, I think the points raised and the range of talks here, I'd say for us as an entire sector, the importance of having kind of a multi-pronged approach in the space is so important, because with our use case with the climate modeling output, there is no way even experienced climate users, if they aren't the ones running the models themselves, don't know how to answer the questions about the what, the who, how was this output produced, and that will never be. Either the information's not there to come and put that together, say, in their own workflow down the track. So really looking at investing in how we support, the readiness across the dimensions, I think, is so critical, especially for the cutting edge side of science and research.
Great. So I might get back to you.
Of course.
You've already said. And I have for Slava and then for Sean, just very quick. Slava, just for your work, what do you use for validation of the results? What is the step for validation in your pipeline? And then for Sean, so you create this field. Well, I have several questions on everything you presented because it's a little bit general level. So, but it creates all this vocabulary of fields, but they're not based in a standard schema, right? They don't follow like DDI. I mean, Dataverse has done the same as Slava knows for many years, right? To create not with an AI agent, but with an algorithm, a rule-based algorithm that gets from the data set, the data file, extracts all this metadata information and creates all the variable information, but it follows a standard schema, the DDI in this case, right? So do you follow a standard schema that you map those fields into, but also the fields at the variable level for every column? That's,
there's a risk there in asking two questions at the same time. But I mean, let's take them in order, okay. Yeah? So Slava, how do you do validation, and then what metadata schema and vocabularies do you use?
The last thing for Sean, though, what is, I mean, when you say is AI ready and responsible, I mean, how do you define that? Because it's not clear to me that any of the things that it shows any responsible certification.
Okay, we've stacked three very good questions there, so hopefully everyone can remember this. Slava.
Okay, validation is a very tough topic, and this is because knowledge is moving, it's live. And especially, you can see now that we separated static library from knowledge itself. And in Croissant, after you're landing to some point, you're querying graph, and you're taking snapshot of all variables and variable cascade and probably data values. And it will become your ground truth at the moment. So the best way, I think, it's just my opinion, just to get all available LM models to be queried simultaneously. You're collecting all results and you're producing new data set and you're comparing them. If there is some kind of, so you have to rely on voices also. So it's not reliable as well because knowledge is moving and you have to do it on a regular basis. This is why Croissant is becoming extremely important if you want also to get all these updates on a regular basis in models.
Do you want to come back on that? I mean, okay. I know there's two questions stacked up, but can we put the online people on the screen, and particularly Deirdre? Because Deirdre might answer that question as well. Deirdre, do you want to comment on your human-in-the-loop process for validation? And maybe how scalable can we make that? What do you do when you hit scale? I mean, I think, Deirdre, are you there?
Yes, Simon.
Yeah.
I think so. Yes, I did impress on you that this is a prototype at present, and we're very conscious that, let's say, if we're talking about one of our bigger studies, and we're asking people, to use human in the loop. Initially, it could be quite, quite cumbersome. Some of our studies have 1,500 variables, and so in order to test some of this, we're using standard validation metrics. So with our classification, we measure using F1 and balancing recall and precision, and I think they're the kind of standard methods. But then on top of that, we're using human in the loop. But we're aware that unless it's at a certain level and that's been evaluated, we're asking too much of our curators. I hope that helps a little.
Thanks, Deirdre. Yeah, I mean, I think that was helpful. Yeah. Okay. We'll go to question 2 and 3. Yeah.
Yeah, I believe that's we do have a schema. We have our own fair square specification that we built on top of other, like what Sean has. So we do have we follow schema.org. We follow, like, we use provenance. Say again? Oh, so we have
the fields and column levels.
so
Doesn't have support for that.
okay.
You have
Yeah, we have a QUDT for units. We have like we are not necessarily right now adopting specific ontologies, but we have like well for few like we have a credit taxonomy, contributor role ontology. We use like some control vocabularies that we have in our specification. We define a schema with shackle, so we use shackle validation. So we do validate that at least we have the fields there. The human in the loop is the one that we trust to validate the values of that we're generating. And then the following question.
The other question was about the responsible AI. In what way do you find the responsibility?
So we're using, Croissant has also responsible AI metadata that we validate. So I know, Croissant, we use the internal validation of Croissant. It does check the fields, but we have our own shackle schema to validate also that we have those fields included in the metadata when we provide the package.
Just one additional part of the responsible aspect is that we do have detailed provenance for every variable with the methodology linked to every variable in the data dictionary, right? So that you can actually have a deeper insight in terms of what can you use those variables for, given that the methodology that was actually used to measure them. And I think that's a critical contextual enrichment, which most usually is missing, but actually is a very important part of responsible reuse. Sorry? Oh, yeah. No.
I have to say, through the process, in order to follow the next step, it has to validate the schema. So we force the human in the loop to provide the information.
So I think one of the contentions behind the conceit of this title and organizing the session in the way that we did was that there's a huge opportunity here for metadata enrichment and semantic mapping. And we can see the power of those tools. But there's also, I think, as Pascal stressed as well, and I think as Slava has stressed in talking about the variable cascade in CDIF, there's also a role for authoritative terminologies and schema as those sources of reference. And I think that's what sits behind Merce's question. In that first article that was published in Frontiers, it struck me that it probably wasn't a surprise that it was a biodiversity article. Because in that field, you have a data source for biodiversity, GBIF, and associated with that, you have a set of very rigorous and authoritative terminologies on species, etc. So, you have a research field which has openly accessible sources of truth and sources of definition. And they doubtless don't have that for all of the variables contained in that article, or, sort of classic, how do I put this? Lists of classic variables, as it were. Some of those have to be handcrafted because of the nature of the data collection. But at least there's a reference framework for some of the key concepts.
Just to speak to that for a moment, I think it's a really important point because, I'm also coming from neuroscience and worked for many years on development of ontologies and standards and schemas and so on. And the controlled vocabularies are essential, right? And of course, all of this enrichment, all of this organization in a standard schema is going to be that much better if you can map to controlled vocabulary. And just as you're saying, this particular example that we started with was already based off of the GBIF, ontology, so it was already useful. And we're not doing at this stage extensive semantic mapping. We are going to, but it's sort of, let's start here. Let's start where where things are clear and defined, and then there's a machinery in place to start to leverage what the community is developing to turn it into something that hopefully is a lot easier to adopt.
So on one of the slides with translations, I actually showed you how to create concept based on description coming from dataset. So we can also ask AI to generate those descriptions, to find all relationships, and in a human loop, we can produce really nice metadata records afterwards, linked to control vocabularies. I think it's already possible, and we can use even multilingual translations support to do that, for example, in Spanish or French.
Okay, if there's no more comments, we have another question from Steve.
Hi, I'm Steve Richard, working in the CEDA working group, among other things. And so this all looks great and miraculous. I'm also working on this Astro Materials Archive and the Cesar sample registration system. And we'd love to be able to upgrade our metadata using these techniques. We have very low budgets. How do we implement something, or how can we actually get in the game doing this? You know, what needs to be implemented, and how do you get it going?
Okay, I can answer. So yesterday it was a very nice session, and someone complained about genomics, and it was discussion that there are no units of measurements, and some other stuff is missing. So what I did, I actually fit inside file in JSON-LD, which was produced by Steve, and I asked model, can you just understand how it's being constructed and do the same for genomics? And it did. So probably we have potential also to teach AI to do the same automatically. And after you will check and we'll confirm.
Sean?
Yeah, just to speak to your point, you know, how do you do this? Where do you get the money? I think one of the opportunities, of course, it depends on your funder, but there is funding increasingly for data management and data sharing, right? And I think a lot of the funders are becoming extremely explicit that you need to budget, you know, for that. I don't know if that applies to your case, but that is what we see as the opportunity, that now there are mandates for making data fair and reshared. And for us, part of the model was, let's also incentivize it that you get a publication. And for a scientist, that's far more interesting than sharing their data, right? It's get something that goes on their scholarly record. So then that can also be paid for with data management money.
Thank you.
Presentation. I'm Mikiko Tanifuji from National Institute of Informatics, studying a large language model in Japan. Now, I'd like to ask, AI for metadata, fine. Metadata for AI readiness, also fine. But overall, what do you plan to give for human, meaning researchers, to explain why these new findings is new? So that it's in research articles, normally you have started structural explanation. At the end, there's a conclusion. This is what I found. And if you read, yes, I can understand almost. And if you want, you can replicate by the reusable data sets if you have a time. But after this AI for metadata, metadata for AI cooperation, and more dynamic science is going to happen, but most of the people would not be able to explain why it's new. And probably it is very difficult to provide evidence, or at least comprehensive evidence, the end of the research papers. What do you think?
So I guess that's addressed to me. But I would say, you know, the fact that we can produce an AI accessible metadata that actually describes, you know, for example, the information that's also going into the article embedded in the metadata means that the AI can interrogate the methods, they can interrogate the properties of the data, and it can say, is there anything else like this, right? And then that in combination with the data article, which has then been peer reviewed and it's been written very much for humans, is pointing out what can this be used for, right? What are the things that are the opportunities for reuse, or what is novel about it? What applications does it have? That information is there, and it's both human accessible and it's machine accessible. And I think that's the key, right? We can leverage infrastructure with AI that can access that at large scale and identify, oh, look at that. There's a new data set that actually finally measures that variable properly. And right now, we have no chance of doing that.
Maybe you were going to say this, but the semantic layer there is going to play the biggest role, that you can compare. If you speak the same language, then you have the same units, then you have the same terminology, then you will be able to see if it's really something new that you can compare.
Yeah, so back to Croissant. Croissant was developed to do integration of data sets. So if you have a very complex question and you have to find data, so what is happening? You will find probably thousands of tens of thousands, millions of data sets, but you're interested in specific column. So in Croissant, you can actually get this information, and after you can go to CDIF and to get information about units of measurement, some other stuff, and create knowledge graph. And this knowledge graph probably can help you to identify, because you'll get integration of all available data sets, and you can train new model on this. And you can ask really complex questions.
Kelsey, Rebecca, do you want to answer this? Where is the new science?
I suppose kind of. Yeah, I do struggle with these types of questions. Obviously, they're tricky questions. But also, I suppose from our perspective at AuScope and how we try to deal with the data and metadata and whatnot, an analogous to the software pipelines that Kelsey was talking about, we look at trying to capture the data at creation. It's aspirational, right? So we try to capture the data at creation and then step through from the raw primary observable data sets through to the products. And I feel like a lot of these discussions are really at that product level. So like in the discussions, like uploading the data. And it's like, oh, that's great, but we've got like petabytes of data. So we're not going to be uploading the data, and we need to have like HPC processing capability and things like that. And so I feel, yeah, the creation of new data, and then it's like those fundamental, I'm not qualified, I've got the doctorate, but it's not actually in philosophy. You know, because I don't know, like at what point is it new knowledge if humans aren't creating it? I don't know. And I get stuck in that loop. You know, because yes, the machines can do it all, but are they?
Yes, I think we need to assess that knowledge. I see what will probably be the last question from Volmar. Before I hand over to Volmar, I'm going to pick up on that question. I think it is important, and I'm going to use it as a segue and a plug for the session tomorrow morning. This session was conceived because we felt there's a lot of work on Croissant and a lot of work on AI readiness and a maturity approach. What do organizations need to do to be AI ready? How do we make data sets AI ready? And also, we're starting to see this metadata enrichment semantic mapping. Tomorrow morning, in the CODATA organized session, there'll be a focus on AI for science. And so we'll have speakers on what is at the cutting edge and examples of how AI is being used for science to create new knowledge, and some policy level and more practical guidelines for relating to AI for science. So I think that session will probably answer your question more than this one. So that's a plug for that session. If you want to continue these discussions, please come along.
All right, thank you. I'm Volmar from Elixir Sweden. I maybe not the funniest question to end with, but instead of the kind of really forward-thinking, more practically. So, I mean, you have these cleaning robots popping up, and you add new features. They get the arm, they can do more things. And I mean, I guess that's the virtuous cycle here. You can have tidy data sets and well-described, and they're going to be easy to integrate. But then at the same time, you have a camera and all these sensors popping up in your house. someone is kind of keeping all the records of everyone's house and maybe pictures and sounds of the environments and whatnot. So, I mean, in comparison to that, what is it that goes into the potentially kind of vicious cycle here? I mean, I'm not really sure how you handle the peer review. Is that something that trains your AI? Is that something that feeds back to the wider community, or is it in your bubble? And I mean, are there other things like that? Like, how do you handle kind of communal improvement in terms of these tools that kind of make life easier?
Good question. Does anyone want to take that?
No, I mean, I think it's an important question. So the peer review model is, of course, publisher specific. Frontiers does a interactive open peer review that then they publish who peer reviewed. We don't take the peer review feedback and use it to train anything. We don't actually use the data to train anything. And we're pretty explicit about that. And we don't ever send the data to a model. But I think that part of our objective is to say, how can we get scientific data to be valued in a way that it can be reused and that scientists are going to actually make sure that it's shared? And how do we build an ecosystem where everybody is benefiting from that? And that we just accelerate science as a whole, because I think the opportunity is we'll all be able to do a lot more. We've all been, dealing with this and struggling with it in various degrees. And the more that we can use some of these new technologies just to make the community able to address a lot of the problems we've been wanting to address for a long time, the better.
So I just want to clarify, I addressed you because you're a commercial actor.
Yeah.
So, I mean, you're not doing the human in the loop for that part. I mean, and you could use the human in the loop feedback for improving the process. Yeah. And if you're not doing that, I mean, still, it could be a case in the future. So I would like to hear from the others as well. I mean, actually doing the human in the loop, and are you using the data? Is that something that people buy into, or what's your reflections on it?
I guess my quick comment on this topic is that we're looking at, preparing for those type of use cases, whether it's, for good, for misuse. But I think for me, the concern is it's even more critical to consider what we're doing in those more foundational early steps of the scientific and research workflows, because you don't know how it's going to be handled down the track or just even misinterpreted. And, that can be a concern. Yeah, climate's a very easy one to think about, whether purposeful or not. And I just wanted to, I didn't get a chance earlier, but I think when you're talking about the fundamentals, that's, probably more closer to where Beck and I sit, that money for data stewardship, I actually think is quite a gap. So I just wanted a quick plug. It is incredibly hard to fund at a kind of systematic scale, so that you don't have that big white gap. I loved your first slide on how much of the untapped research data just gets left behind. And I think a big part of that is that people are time poor and there's never going to be enough money. So we have to kind of have that an approach where you do get that funded into other mechanisms, and wherever you can have that be core. So I know it doesn't directly address it, but to me that's so critical, so that you don't have, or you prepare yourself for some of the vicious kind of aspects.
Thanks. I'll start to close up this question, this session. I will make a comment on that and some of our thinking in using that terminology. It's very exciting to see the opportunities for metadata enhancement. We've spent decades saying, oh, there's not enough resource, it's too much effort. Maybe now we have tools that can help us. That sounds very exciting to me. And I think the points that have been made about having the authoritative terminologies and ontologies can really help us as well guard against that vicious cycle. What I'm going to say now, though, having spoken to Sean, I'm sure that this is not the objective either of Frontiers or of SenScience. But you can look at this and say, there is a risk here. It becomes easier and easier and easier to create an article, to create a data set. And we see now with so-called paper mills, etc., how publishing as part of your career is becoming easier, it's becoming paid for, and it's becoming there's a lot of bad science out there, to be frank. Let's say. And this is also a risk. This is a risk with the amazing facility of generative AI to create text, and it's also a risk with the facility of generative AI to enhance data. So I think there are risks here. We didn't really discuss those much in the session, but I think that perhaps might have been some of your thoughts behind your question, Volmar, not wanting to put words in your mouth. So these are things that we need to be careful of as well as we go down this road. We can't help but go down this road. It's because it's happening. But we need to think about what can be done to make sure that that quality is maintained. I didn't really want to end on that sort of note, but I have accidentally, and I didn't really want to end on me having the last word, but we've run out of time. So we will. So can we thank all the speakers on the... and those online. And I hope that you can continue some of these questions and ask our colleagues about what they will do about quality in metadata and semantics. And yes, come to the session tomorrow. Well, yes, there was a session this morning that looked at rigorous, responsible research, and tomorrow AI for science, where we'll deal with some of these issues. Thank you very much.